Okay, I think we'll start now. Okay, so let's look at the first question here. So first one, find the general solution of this DE. Okay, giving your answer in the form of y is equal to fx. So basically, this is the usual thing. Okay, that we do to solve this DE. The first thing is we separate. Okay, the variables. We have the y and the x. Okay, the first step is we separate them. So after we separate them, this is actually what we actually get. And for the left hand side, it's 1 over y dy. It's very easy to integrate from there. And for the right hand side, if you see that we have got 1 over x times 1 plus x squared. Okay, so for that one, okay, we actually need to do the partial fraction first. Okay, because in our denominator, the terms there, okay, can be actually simplified. Okay, so we have to use the partial fraction first. So when we actually do the partial fraction, okay, we actually have 1 plus x times 1 over x squared, okay, can be written in the form of a over x. And another one, because the factor that we have here is a 1 plus x squared. So 1 plus x squared is something that cannot be factorized into linear. So that is a quadratic factor. So if we have a quadratic factor which cannot be factorized, our numerator must be a linear. Okay, so this is why we put a bx plus c, okay, as our numerator, okay, for the 1 plus x squared. So from there is by cross multiplying this one, okay, we cross them and then we actually have this expression. So we only look at their numerator now, and basically next thing is just we substitute the suitable values for the x in order for us to solve for all the values for the a, b and c. Okay, so we can actually try to substitute like 0 to give us a is equals to 1, and for b and c maybe we need to use 2 different values of the x, and we have to solve, okay, the value from for the b and c from there. So after we solve the b and c, okay, we actually have the partial fraction, okay, is in this one. Okay, so this would be the partial fraction. And after that, okay, we can actually move on to the integration. So for left hand side, we have got 1 over y to integrate, and the right hand side is basically our partial fractions. Okay, so for the terms 1 over x and 1 over y, we know that when we integrate, we get ln y and ln x from there. Okay, this one is quite usual. And if you look at this term here, so for this term, right, we actually have 1 plus x squared in the denominator, and the numerator we have got an x. So this is a fraction, and if you have a fraction, we can always check that we will actually have the denominator, which is 1 plus x squared. Here we can see whether are we able to get the numerator, okay, when we actually differentiate the denominator. So in this case, we have 1 plus x squared. If we differentiate, we can get 2x, which is something similar to the numerator. So when that happens, okay, we can actually know that this, after we integrate, we will actually get something which is in a ln, okay. But like what we did just now, we have 1 plus x squared, we differentiate, we get 2x, but in our expression, we only have an x from there. So we need to adjust the constant. So what do we mean by the adjust the constant is that we need to have 2x in our numerator. Okay, so we multiply 2 to the numerator. So to cancel out the effect, at the same time, we need to divide by 2, okay, outside the integral. So this ensures that when we actually integrate this, okay, we get the ln of 1 plus x squared plus a constant. Okay, so for that, okay, what we have for that one is, okay, we actually have all the ln terms here. As we can see, we have got ln, and ln here, and then this is a constant term. And what we did here is for the half, right, we already move it, okay, to become the power of the 1 plus x squared. So that would be square root of a 1 plus x squared. And what we did from this c to the ln a is that because we want to simplify the expression. So again, our c is just the same as the ln a because they are just constant. C is constant, ln a is also constant. Okay, as we can, as we did from some similar question that we have earlier. Okay, in the integration, if I'm not mistaken. So with that, we can combine all the ln terms. So because we have got ln x minus ln 1 plus x squared. So minus means we have to divide this one, and this is a plus, so we actually multiply by a from there. Okay, so combining the 3 ln terms here, this is what we get. Okay, and cancel off the ln, we will actually have the expression that we need, okay, from there. Okay, so that will be the solution for the first question. Okay, next one. So solve this DE when y is equals to 2 and x equals to 1. So express the solution in the form of y is equals to fx. So basically for this one, it's not really difficult to do. We just need to separate the variables. We have y and the x, okay? So when we actually separate the variable, so this is one possible case that we can actually separate. Okay, depends on where you want to keep your negative. Okay, so you can keep your negative at either side. So for this one, okay, after we integrate these two, okay, we have got negative 1 over y squared and x power 3, we will get 1 over y and 1 over 4 x to the power 4 plus c from here. So of course, at this stage, what we need to do is we need to find out what is the value of the c, because the value for the x and y are already given. Okay, so we use these values to find the c. So if we find the c from there is a 1 over 4. Okay, just substitute back, okay, what we have for the c, which is 1 over 4, and then we can actually just try to combine the two terms together into a single term, and then we in this case we just have to flip, okay, because we want the expression which is y in terms of x, so we can actually just flip from there. Okay, so this is the expression for y that we can actually get. Okay, so not really difficult for this one. Okay. Next, okay, so okay, we have got a tank with vertical sides, okay, and rectangular cross section is initially full with water. Okay, so this is important. Initially full with water. Okay, so the water is leaking out a hole at the base of a tank at the rate which is, so this leaking rate is proportional to the square root of the depth of the water. So V is the volume, okay, and the time is given by T, and the unit of time here is hours. So first show that dV dt is equal to A root V, where A is a constant. Okay, so for this one, okay, we have to define some variables first, because there's a lot of things that they actually never gives us. So first, when they actually talk about the depth, okay, we need to define this variable, so it's easier for us to do our work later, which is h, okay, and from there, okay, from the second sentence here, they say the rate of the leaking is proportional to the square root of the depth. So this is what we have. Okay, for the dV dt means the rate of change of the volume. Okay, and then in this case, because the water is leaking, so the volume should be decreasing. Okay, so we have to put a negative for that one. Okay, so this is from what we get from the second sentence, but it is not really what we want to prove yet in the next part. So later on, what we have is we have the base area is equals to A. So this is also something that we define, because we do not know, okay, what is a base area. They never give us a base area here. So for this base area, okay, we know that the volume, okay, is given by AH. Okay, it's a base area times the H, because for this tank, okay, because we have got the base area is fixed. Okay, so only the height, which is the depth here, will change, okay, with respect to time, but the base area will never change. So from there, okay, we can actually have the A is a constant here. A is basically a constant. So what we have is, because we want to have the dV dt, okay, from the question, we want to have the dV dt, which is in terms of V only. So we can actually just manipulate this one. So in this case, the H is a V over A. So we just have to substitute the V over A inside, okay, our dV dt. So just have to move out, okay, the root A, and for this, okay, we already have the square root of V, okay, that one is what we need to prove. And for the negative K over root A is just a constant, because in the question it is already stated that our A is a constant. Okay, so negative K over root A is a constant, so we might as well just replace that with a single constant, because we still have to calculate that later. Okay, so we just replace the constant with the A. So this is how we can actually prove the first part. Okay, so that's for first part. Second part, if you look at the question, they say, okay, given that the tank is half full after 1 hour, so show that the V is given by this expression, where V naught is the initial volume water in the tank. So if you actually look at the question again, okay, the beginning part, it says it is initially full of water. Okay, so this is one useful information for us. Another information is after 1 hour, the tank is half full. Okay, so that is going to help us in calculating all the constants and things like that. Okay, so of course, before we can actually do that kind of the calculation, like all sorts of the constants, we need to solve this equation first. Okay, so for that, okay, we can actually move the root V to the left hand side. We get V to the power of negative half dV, which we need to integrate. And for the right hand side, we only have A, the constant, to integrate with respect to T. So for the left hand side, after we integrate, we get 2 root V. And for the right hand side, we get AT plus a C. Okay. So after that, okay, by using the values that is given, so we know that we have when initially, so initially means when t is equal to 0, the V, the volume, is given by V naught. V naught is a value which is the volume, okay, of the tank when it is full. So when we actually substitute t, okay, we actually get the constant here. The constant is a 2 square root of V naught. So this is the value for our constant. Okay, so further from there, we need to actually find out, okay, what is the value for the A, since we have got the value of the C already. So we substitute another value in. So this is when after 1 hour, the volume is half, okay, of the original. So in this case, the V is a half V naught. Okay, so from there we just have to simplify a little bit. So substitute the V into here, this is our V, okay, and this is our C, okay, based on what we have from there. So just tidy up from there. Okay, so work with the constant. We have got root half and times 2, so we get a root 2, and we just have to move this term over, and this is the A that we get. Okay, so that is for the A, and we have to put this A back into the equation again, and we have to tidy up a little bit. So we put in our A, this is our A, and this is our C. Okay, so in order for us to solve that easier, we can actually factorize out the root of V naught. And next thing we can do is we can actually throw the 2 over to divide, okay, by the terms in the bracket. So in the bracket, we actually have this whole thing to be divided by 2. So this is why we get a constant, which is a 1 here. And then for this root 2 divided by 2, we get 1 over root 2. And 2 divided by 2, of course, we get a 1 from there. So the step after that is we just have to square both sides. Okay, so after we square both sides, we will actually get exactly the thing that is required to prove. Okay, so it's about manipulating the expressions carefully from there. Okay, so next one, okay, is we look at the question again. So next one, it says show that the tank will be empty after approximately this time. Okay, so tank is empty means the V is a 0. Since we already proven, okay, in the second part, so we just have to let the V to be 0, and basically we're actually solving for this thing. Okay, so from there what we have is we just have to manipulate a little bit this expression, and okay, and then at last we'll actually get the T to be this value. And remember the T here is hour, so we have got 3.4 something, okay, for the hour. So we know we have 3 hours, and then the 0.4, okay, we need to change it to the minutes. Okay, so we multiply by 60 minutes with the decimals, and it will actually gives us the minutes. Okay, so in this case we have already proven the time is given by this. Okay, so that would be for this question. Okay, next one. So differential equation is given by this. And first express 2 over y1 minus y in partial fractions. So for this one is the usual partial fraction. So we can actually write the 2 over 1 times 1 minus y in this form. And for partial fraction, I guess you already know how to do, okay, all of that. So we'll actually get this, okay, as our partial fraction. Okay, and part 2 is to show by integration that we have got this relationship. So from here, okay, we need to separate the variables. Okay, so when we actually separate the variables, okay, we'll actually have the left hand side that we have got here is actually exactly the same as what we have in the first part. Okay, so we can just apply the partial fraction from the first part and just integrate accordingly. Okay, so if you look at the right hand side here, the right hand side is just to integrate the 1 dx, so we'll get x plus c. So we remember to put a constant, okay, after we integrate at either side. So for the left hand side, we have got 2 over y. So 2 over y, we get 2 ln y after we integrate. Okay, so there is one thing that is always like very easy to make mistake, is that we are trying to integrate 1 over y. 1 minus y in the denominator. So when we actually integrate, okay, other than getting 2 ln 1 minus y, remember when we actually integrate this, we have to divide, okay, this term by the coefficient of the y. So in this case, the coefficient of the y is negative here. So after we integrate, we should have negative, okay, as the coefficient for the ln 1 minus y. Okay, so we have to be really careful whenever we integrate something like this. Okay, so after that is to combine the terms that we have. So because we have got ln minus ln with a 2, so we can actually sort of like factorize the 2 out, and then we just work with the ln. So minus means divide the y with 1 minus y. And next we can actually move the 2 to become the power. Okay, so okay, after that, okay, what we can do is for this ln, we can actually just bring it over and raise it to be the e. Okay, so we have got e power x plus c. Okay, so for that one, we actually have for this case, it is e power x times e power c. So for this e power c, we just make it as a to be easy. Okay, because again, e power c, a, they are just the same thing, they are just a constant. So for this, okay, it is the y over 1 minus y squared, and then we just have to expand the square lah, okay, and put it in the numerator and denominator, and this is what we get, okay, from the part 2. Okay, so that would be for part 2. And for part 3, okay, it's given that we have got the value, okay, that we have got x equals to 0 and y is equals to 2. So we need to find the value of the a in this case. So since we already have the result in the part 2 already, so basically just substitute the values of the x and y in. And very easily we can actually find out what is the value for the a in this case. Okay, so substitute back, okay, what is the value for the a in this case? Okay, and for this question, there is a catch, okay, for this question. So it's really worth to look at, okay, for this question. So usually when we actually have the a is equals to 4 in this case, okay, this is what we get, we have 4 already. And because for this one, this is like we have got squares, right? We can actually move the squares over to take the root. Okay, so when we actually take the root, of course, okay, we know that for e power x, when we take the root, it means the e power x has to be powered by half. Okay, so this is why we have got we have got e to the power of half x. And there is one thing that we have to be really careful here, because when we actually solve for the equation, right, when we actually take the square root, we need to always consider the plus and minus. So when we take the 4, of course, the root is 2, but there is a plus and minus here. So we need to decide, okay, whether we want to take plus or minus from that. So in this case, okay, we will have to take the value for negative, because the reason is that, again, okay, given this value. So if we actually check the value for the left hand side, when we sub in a 2 into the left hand side here, we will actually end up with a negative 2. Okay, so negative 2 is here, lor. Okay, because when x is equal to 0, okay, when x is equal to 0 here, this thing is equal to a 1. So we will have to take the value which is a -2. Okay, so that's why the plus and minus, we will actually choose a negative of that, because again it is taking a square root, so they might be positive or they might be negative. So this is a catch, okay, of this question. So after that, okay, once we actually confirm that this is a negative already, so just be careful on this one. And we just have to express y in terms of x. So basically is to multiply the 1 minus yr and collect the y together, factorize the y, and then we just have to move the rest, okay, to make the y as a subject. So the things which follow by that is not difficult to do. Okay, so we have to be really careful on this one. No? All right. Okay, next one. So okay, so for this one, it's quite a useful, quite a usual question that we have seen, okay, in a lot of cases, which is related to the Newton's law of cooling. Okay, so I guess I won't really go into details for this one, since you should be able to know how to solve already, and we will only look at the part 1 for the explanation part. Okay, so for the part 1, okay, for this one, explain why the rate of change of the temperature is given by dt over dt is equal to negative kt minus 20. So we have got a lot of things to explain from there. Okay, so for the questions which involves the explanation, it is good for us to actually explain as much as we can and as clear as we can. So every single thing that contributes to the expression, okay, we will actually have to explain a little bit. So we have got dt is a rate of change of the t, and also we have got the second point here is a t minus 20. So what is meant by the t minus 20? It is a difference between the t and the room temperature. And then also we have got the k, okay, the k is the constant of the proportion. And why is it negative? Because the temperature is decreasing, things like that. So be clear, just in case we might miss some marks from there. So be as clear as we can. Okay, so for the second part and the third part, the second part, okay, it is already given, so I won't actually go through, okay, for that one. For the part 3, okay, find the value of k, okay, so you can actually refer to the value of the k here. Okay, so I'll just show the working for you so that you can actually have a look at it. Okay, so this is for part 2 and this is for part 3. Okay, so for this question, it shouldn't be very difficult to do. It's quite usual. Okay, so from there we can move on to the next one because we still have a few questions to look at. So, okay, this one. So a patch of disease on the leaf is being chemically treated. So at time t days after treatment starts, its length is x cm, and the rate of decrease of length, okay, the rate of decrease of length is observed to be inversely proportional to the square root of its length. Okay, so from there we can actually start to form the equation already. So they say the rate of change of the length, because in this case the length is x, is inversely proportional, okay, to the square root of the length, which is again x. So it's inversely proportional, so we have to put the root x in the denominator, and then proportional thingy, we have got the k, okay, the constant of proportion, and it's decreasing, okay, the rate of decrease. So this is why we need to include the negative here. Okay, so that is our equation. So okay, from there, so what we have is, okay, the first question, the first part that we say that we have here is at t is equal to 3, x is equal to 4. Okay, at this instant the length is decreasing at 0.05 cm per day. So what is given by this part of the description here? So this part of the description here gives us the dx dt. Okay, and for this case, the dx dt is negative 0.05 because it's the rate of the decreasing, because it says 0.05 cm per day. So it is the rate of decreasing, which is dx dt when t equals to 3 and x equals to 4. Okay, so just substitute the values for the x inside, and then we have got the dx dt is equals to negative 0.05, which enable us to find out what is the value for the k in that case. Okay, so we have the k which is 0.1 to work with. Okay, so next one. So for next one, right, okay, we actually have to from here, okay, from this equation, we have to rearrange the variables, okay, separate the variables into x and t, and we just have to integrate accordingly, not difficult to integrate from that. Okay, so after that we have to sub in the values again. So we know that when x equals to 4, t is equals to 3, okay, from the question given, okay, it's given in the question. So substitute the values for the x and t inside and give, it will give the value for the c in this case. So basically what we do is we just have to put in, okay, the constants, okay, the c, and then this is the value that we get. And any other form of the answer will actually be accepted as well lah. Okay, so you can also multiply this whole equation by 10, and you also get like 20 over 3x cubed, because for this case you can actually get the t without a 0.1. This is another possible answer that you can also express in. Okay, 3 over 2. Okay, so any equivalent form will do, right? So last part of the question, it says hence find the time it takes for the length to decrease to 0.01 cm. So this is when x is equals to 0.01. okay, we need to find out what is the time. Okay, so basically it's again solving, okay, the equation. So solving the equation is not difficult to do, so we will actually get this amount of time, which is 56.3 days. Okay, so that will be the solution for this. Okay, let's move on. Okay, for this question, right? Okay, find the solution of this differential equation xy squared dy dx equals to x plus 1 given when we have y is equals to 3, x equals to 1. So give your answer in the form y is equals to fx. Okay, so for this one, first is to separate the variables. Okay, we have got y squared dy for the left hand side. The right hand side we have got x plus 1 over x. Okay, so for the x plus 1 over x, it is not really friendly to work with if you want to integrate. So unless we actually split the terms, so we actually have 1 plus 1 over x for the terms. For the left hand side, it is super easy to integrate. Okay, we get 1 over 3 y power 3. So now we have to integrate the right hand side. So it will be x plus ln x, okay, plus a constant. So next is to substitute the values, okay, x equals to 1, y equals to 3 in the equation that we have got, and get, okay, what we have, okay, for this constant. The constant is 8 here. And just put everything back, okay, to the equation, okay, the relationship that we have. And for the 1 over 3, just move, okay, to the right hand side to become a 3, and we have got the cube here. Okay, when we move it to another side, it will become a cube root. So the value will be the cube root of this expression, or any other equivalent form of this expression will do. Okay, so that is for this question. Okay, let's look at the next one. Okay, for this one. Okay, for this one, okay, using partial fractions, okay, find the general solution for this differential equation. Okay, so for this, we have got this, okay, differential equation given. So of course, the first step is always we have to separate the variables. We have got x and y. Okay, we need to separate them. So this is what we get after we separate them. And for the left hand side, right, we can actually see that our denominator can actually be factorized. Okay, it is actually y times 1 plus y and 1 minus y. Okay, so that will be the factorization for the denominator, and from there we know that we can actually write them as the partial fraction. Okay, so the work that we need to do for the partial fraction, I won't actually go through in detail. So we should know how to work with the partial fraction, and at last, this is the partial fraction that we're actually getting. Okay, so integration, the right hand side is x plus a constant, and as for the left hand side, we have got 2 over y, we get 2 ln y. So negative, okay, negative of 1 over 1 plus y, after we integrate we get 1 plus y, ln of the 1 plus y, and the term, the sign or the coefficient is still a negative. Okay, but just have to be careful on this one, no? So this one is 1 over 1 minus y. After we integrate, we get ln 1 minus y, but the coefficient here, it becomes negative already, because remember, we need to divide, okay, this term by the coefficient of the y, which is negative 1 in this case. So it will become a negative. Okay, so after that is to combine all the ln terms. So for this one, because we have got 2, right, so it can actually be written as ln of y squared. And we have got 2 minus ln here, so it will actually become the denominator inside the ln term with the y squared for the numerator, because that is the positive term for the ln y squared. And after that is to move the ln over to get the exponent. And again, this is the same case. We have e power x times e power c in this case. So the e power c has, we just make it to be a in that case. Okay, so after that is to multiply, okay, the 1 plus y, 1 minus y, we move up, okay, to get 1 minus y squared, and we just have to tidy up from there. Okay, so we expand and we get y squared term. So collect the y squared term together and just make y as a subject from there. Okay, so it's a little bit of the simplifying work from there lah. Okay, so that will be for this question. Okay, last question that we'll look at. Okay, so this is about the population. Okay, so it is already given nicely the equation for the population. Okay, and just take note that the t is measured in years lah. Okay, the time unit is important, so we have to be careful all the time. Okay, so it is mentioned that, okay, the biologists, okay, initially stocked the lake with 500 salmon. So estimated the number of salmon had reached 2,000 after 3 years. So these are very important infos that they actually already give us. So first, okay, solve the DE to show that we have got P is equal to this expression. And we also have to find out what is the value for the K in that case. So it is not difficult to start with for this equation. So as long as we move this P and 12,000 minus P to the left hand side, okay, and we can, from there we can actually integrate. So for the right hand side is a K dt if we choose to leave the K at there. Okay, so for the left hand side, again we see that in our denominator it is something that is factorized. Okay, so if that is the case, we need to do partial fraction again. So we have to do a lot of the partial fraction in this case, especially in the differential equation. They like to ask something like this. So for the partial fraction is we have got a over p plus b over 12,000 minus p, and just do whatever that we need to do, substitute the values, okay, to find out what are the values for a and b. Okay, and for the a and b, it is just a nice 1. Okay, so this is why we get this expression. Okay, so after we integrate, we have got 1 over p, which will get ln p from there. Okay, it's very usual. And for the 12,000 minus p, right, we will get ln of 12,000 minus p, and again the same thing again. So the coefficient here is a negative because of the negative p. Okay, the coefficient of the p here is a -1, so we have to divide the term by -1 after we integrate, so we actually have a negative here. Okay, so this thing happens very often, so you have to be really careful. Okay, right hand side, not an issue, we can always do, okay, which is kt plus a c. Okay, not an issue from there. So from there, we can actually find out, okay, what is the value for the c in the first place. Before we actually find the k. So this is usually what happens. We will usually find the constant first before we actually find out what is the k. So it is given earlier in the question like we see just now. Initially, the population is 500. So substitute the p equals to 500 into our equation. And we actually have the c is a ln of 1/23. Okay, because in this case, the c that we have is a ln 500 over 11500. Okay, so which we get ln 1/23, which can be also written as negative ln 23. Okay, so in case if you forgot why is it like this already, because 1/23 can be also written as ln 23 to the power of -1, and we can always move the power to the front. Okay, so this is why we get ln 23, and then in fact we can actually just throw away the modulus already, because the 23 is already a positive number. Okay, so we choose to use this, we can choose to use either one. You can choose to use a ln 1/23 or negative ln 23. It's up to you. We will actually end up with the same result. Okay, so we will actually have this is the expression. Okay, ln p minus ln of 12,000 minus p equals to kt minus ln 23. Okay, so from there we will actually tidy a little bit, because we need to find the k in this case. So let's say, okay, we actually try to express, okay, the value, okay, express the p in terms of the t first, because that is in a earlier part of the question. Then later they only ask us to find the value of the k. Let's say we just express first, okay, without finding the k. So expressing that is to combine all the ln terms, remove the ln over, it will become a positive 23. That's why it appears in the numerator. And for this is a minus, so it will actually appear in the denominator. And next is we bring the ln over, then we will have exponent. Okay, and from here it is very familiar to us already. We just have to move the term up, expand, and just collect the p together in this case, and then we will actually get something like this. Okay, we might get something like this, or we can actually get the answer straight away. So in case if you actually get something like this, to make sure we get the same form that we have, like what we have in the question, we just have to multiply the numerator and denominator by e to the power of negative kt. Okay, so we will actually have this expression, which is exactly the same as what we need in the question. Okay, so now is to find out what is the value for the k in this case. So the value of the k, it is not necessarily that we must use this, okay, to solve for the k. If we use this to solve for the k, we have to like do a lot of rearrangement again. So another easier equation to start with is basically the first line. Okay, by using the first line, it might be easier for us to find the k, because the k is already there. Okay, it might be easier for us to work with. So or you can use any other line that any other thing that you like lah, or you can use the second line, is even easier, because the k is readily available to express. Okay, so by using any method, okay, we have t equals to 3, the p is equals to 2000. So sub the values in, okay, and then we can actually find the k very easily. Okay, and this is the value that we need to prove for the k. Okay, so that will be for the second part. The third part, the second part here is state the maximum number of the of salmon which the lake is expected to support, and justify your answer. So whenever they have something like this, okay, it's usually about what happened when we have the t goes to infinity, because the population will actually grow, okay, keep growing, but it will actually like grow until a certain number, and we cannot exceed that number. So this kind of the question, or this kind of situation usually happen when we have in our expression, okay, we will actually have like some exponent term. Okay, so what happened to this one is we are looking at when t approaches infinity. So when as we keep the leg there for a very long time, okay, which we have the t equals to approaches infinity, the e power negative kt approaches 0. So remember the graph for e power kt is like this. So when we have the time, okay, goes larger and larger, the value for the e power kt will also goes to a 0. So it's very close to 0, but it will never goes to a 0. It is very close to 0, or we say it approaches 0. Okay, so if the e power negative kt approaches 0, if we actually look at the expression again for our p, so this is our p, okay, we look at this one. If this term approaches 0, okay, so in that case our p will also approaches 12,000. So 12,000 is our maximum number of the population already. We cannot go any further than that. Okay, so this always happen when we actually look at the value for the exponent term. Okay. Okay, so that is it for the differential equation. Okay, so I'll upload another set of the question for you all tomorrow, which is about the vectors. Okay, you all can try to work on that, and I'll upload the solution as well. So that will be the last session that I will have with you all. So you can take time to do your revision, and all the best in your exam. Okay, if you have any question, you can always WhatsApp me lah. Okay, thank you everyone.